What is the difference between the heat engine and heat pump? Heat engines produce work. Work is done on the surroundings. On the contrary, a heat pump requires work as input. Heat engine extract heat from a high temperature source, convert a part of it into work and reject the remaining to a low temperature sink. However, the opposite happens with a heat pump. When user supplies work to a pump, it extracts heat from the low temperature source and pump it to the high temperature source. Heat engine produces mechanical energy, whereas heat pump requires mechanical energy. In heat engines, not all the heat supplied gets converted into useful work. If all the heat supplied is converted into work, then it will definitely violate the second law of thermodynamics. Similarly, using a heat pump, you cannot pump heat from a cold body to a hot body without the input of external work. If no external work is done on the pump, and if the pump pumps heat from a cold body to a hot body on its own, then it will also violate the second law of thermodynamics. The sweet and short answer for this question would be: heat engine produces work and transfers energy from high temperature to low temperature. In a heat pump, external work is needed to transfer energy from low temperature to high temperature medium. Why is reversed Carnot cycle is not possible practically? Because adiabatic processes are not possible due to losses in the condenser pipes, compressors, and evaporator. Give the names of different thermodynamic processes. First would be isothermal process, which is a constant temperature process. Second is isochoric process, a constant volume process. Isobaric process is the constant pressure process. Throttling process or isenthalpic process is the constant enthalpy process. And last but not the least, we have isentropic or adiabatic process, which is a constant entropy process. Explain the Otto cycle in brief. An Otto cycle is an idealized thermodynamic cycle that describes the functioning of a typical spark ignition engine. It is the thermodynamic cycle which is most commonly found in automobile engines. The answer to this question would be: Otto cycle can be explained by a pressure-volume relationship diagram, as you can see here. It shows the functioning cycle of a typical spark ignition 4-stroke engine. The cycle starts with an intake stroke, closing the intake and moving to the compression stroke, which starts the combustion, followed by a power stroke. Then comes the heat exchange stroke, where heat is rejected, and finally the exhaust stroke. It was designed by Nicholas Otto, who was a German engineer.